Okay, guys, welcome. Today we're going to talk about how to do some arithmetic operations with fractions. So we'll talk about how to add, subtract, multiply, divide fractions, right? Now, a lot of people don't like fractions, and I realize that. So we're going to start off nice and slow with these, but we are going to work a lot in this course with fractions, so it's important that we're comfortable with this. All right, so just some terminology before we get started. When we multiply two real numbers, we call each of the numbers that are being multiplied together a factor. And of course, the result is a product. All right, now in this course, I'm going to use the dot symbol most of the time for multiplication, or I'll just simply write the numbers next to each other. So if I write something like xy, it's sort of understood that x is being multiplied by y in that scenario, right? Now, I'm going to avoid using x to symbolize multiplication just because most of the time we reserve x for the use of a variable, right? So I'm going to avoid using x most of the time for multiplication. All right, now when you divide two numbers, you have, right, like in multiplication, each number is just a factor, but in division, the order matters. So we sort of, we indicate that that order matters by two separate words, right? So if you have something like 3 divided by 2 or something, the first number that you see is called the dividend. And then the second number that you see is the divisor. Right, and then whatever this equals, so of course this is just 1.5, your answer to a division problem is just a quotient. All right, and for the most part, I will avoid using this symbol for division, at least for the most part. A lot of times I'm just going to indicate division with a fraction, right? These two things mean the same thing. All right, so just keep that in mind as well. Now, when you're looking at if you're looking at an algebraic expression, you just need to remember to use PEMDAS. All right. Now, one thing that sort of gets lost in translation at some point is when you're doing PEMDAS, you almost want to think of multiplication and division together. You also want to think of addition and subtraction together. All right. So what I mean by that is each of these two steps are performed left to right as they appear. Right? So of course, when you're looking at an algebraic expression, your first one, your parentheses, you do that alone, right? Parentheses or any other grouping symbols, you do that first. Then you handle your exponents, right? But multiplication and division are done together. It's not multiplication and then division. You do multiplication and division together as they appear from left to right, and you do a similar thing for addition and subtraction. Now, one example where you see this sort of matter a lot is on social media. There, every once in a while, there'll be one of these things that go around that say 98% of people get this wrong. What's the right answer, right? Most of the time, people that get that wrong are not applying PEMDAS correctly, right? So for example, in part A, just to look at an example here of PEMDAS, we have 2 plus 3 times 4 minus 5. Now, if you have a single number in parentheses, there's not much you can really do with that, right? So that's sort of what's going on in this example. Now, there's no exponents, right? So we don't have to worry about that either, right? So this is currently what we have. All right. Well, now the next step is multiplication and division. And of course, I do have multiplication. So I have 3 times 4. So that's going to become 12. And I didn't do anything else with these two yet. So they stay. Now, if we perform addition and subtraction from left to right, well, these two come first. So that's 14. And then I have 14 minus 5. So I'm going to get a final answer of 9 for this. All right. Now in part B, we have 10 divided by 5. plus 7 plus 3 times 6. All right, so again, here we have no parentheses or exponents, so we can go right to multiplication and division. So of course, the first one that comes up is we have 10 divided by 5, so that's 2. And then I have 2 additions, so, which I'm not worried about yet. But then I have multiplication. I have 3 times 6, which is 18. Right? So then if I add them up, 27. All right, last but not least, part C. We have 2 times 4, of course, which is 8, minus 6 plus 3. And if we do this from left to right, we're going to get a 2 plus 3. So when all is said and done, we'll get a 5 there. All right, so just be careful when you're doing your PEMDAS that you sort of treat multiplication and division together. Okay, so now we can start talking about how we can do this with fractions, right? Now, when you're looking at a fraction, the number on top is considered to be the numerator, and the bottom of the fraction is the denominator. All right, a lot of times just to save time and save my breath, I'm going to say top and bottom, but to be mathematically proper, we would usually say that the top is the numerator, bottom is the denominator. Okay, so the first thing we're going to talk about is multiplication of fractions, right? So if you want to multiply fractions, all that you need to do is you multiply the 2 numerators together, and that gets your new numerator, and you multiply the 2 denominators together, and that gets you the new denominator, right? So multiplication of fractions is very straightforward, right? So as an example, let's look at a couple of these. So in part A, we have 3 over 5 times 7 over 2. So if we want to multiply these, I just need to multiply the 2 numbers in the top together, and that's my new top, and multiply the 2 numbers in the bottom together, that's my new bottom, right? So if I do 3 times 7, that's 21. If I do 5 times 2, that's 10. Now, we're going to talk about later how to simplify fractions, but it turns out that this one is already simplified, so that's our final answer there. All right, for part B, we have 2 over 9 times 5 over 3 times 4. All right, now this is a little bit odd because we have fractions and whole numbers here. All right, now if that happens, you just want to make every number into a fraction. Right, how do you make 4 a fraction? You put it over 1. So now the same thing applies. If we multiply all of our numbers on the top together, that's my new top. If I multiply all my numbers on the bottom together, that's my new bottom. So if I do 2 times 5 times 4, I'm going to get a 10 times 4, so a 40. And in the bottom, I have a 9 times 3 times 1, so that's going to give me 27. And of course, this is already simplified as well. All right, for part C, we have 4 over 3 times 7 over 3. And of course, if we multiply these two, I'm going to get a 28 over 9. Right, and then last but not least, part D, we have 5 over 12 times 7 over 3 times 1 over 2. So it looks like in the top, we're going to get a 35, right? 5 times 7 times 1 will give me a 35. And in the bottom, I get a 12 times 3, which is a 36. And if I multiply that by 2, I'm going to get 72. So I get 35 over 72. All right, so that's how we're going to multiply fractions. Okay, now before we talk about division of fractions, we need to talk about what's called the reciprocal. All right, now the reciprocal of a fraction is just found by switching the numerator to the denominator and the denominator to the numerator, right? So for example, if you have a number 3 over 4, the reciprocal is 4 over 3, right? You just switch the numbers from the top to the bottom, and you just switch them, right? One thing that you have about reciprocals, one sort of interesting fact is that if you multiply a fraction by its reciprocal, you always get 1, right? And so, like, just look at this example that we just had. If we multiply these two things together, I get 12 over 12, which is, of course, 1, right? Now, you'll note that every real number, of course, except for 0, does not have a reciprocal, because if you have 0 over 1, you're going to get 1 over 0, and this is no good, right? So 0 does not have a reciprocal. Right? So that's one thing to keep in mind. Okay, so now that we've talked about reciprocals, we can talk about how to divide fractions. So if you want to divide fractions, all that you do is you're going to find the reciprocal of the second number, and then you just multiply the original first number by the reciprocal of the second number, right? Now, growing up, a lot of students are taught what's called keep, change, flip, and I think this is nice. All right, and we'll sort of showcase that in the next one. So in this example, if I have something like 4 over 9 divided by 3 over 5, how do we do this? Well, we take 4 over 9, and instead of dividing by 3 over 5, we think of it as multiplying by 5 over 3. And now we just do what we did before. If I multiply the two top numbers, I get 20. And if I multiply the two bottom numbers, I get 27. Right? And of course, you can sort of see keep, change, flip in work here because we kept the first number the same. We changed division to multiplication. And we flipped the second number. Right? So that's sort of one thing that you can use to help you remember what to do when you're going to divide fractions. Right? In part B, we have 2 over 3 divided by 5 over 7. So we'll keep, change, flip this. We have 2 over 3 times 7 over 5, and we'll get 14 over 15. Okay. For part C, we have 8 over 7 divided by 3 over 2. So we'll change this to 8 over 7 times 2 over 3, and we get a 16 over 21. All right, and last but not least, part D, we have 1/2 divided by 3. And of course, we want to think of 3 as 3 over 1. So we get 1/2 times 1 over 3, which will give me a 1 over 6. All right, so that's how we divide fractions. Okay, now we're going to talk about equivalent fractions, right? So what do we mean by equivalent fractions? Well, we mean fractions that look different but really have the same value. Okay, so for example, we have the fractional values here. We have 3 over 2, 6 over 4, 18 over 12, and 72 over 48. All right, now I'm saying that those are all equivalent. All right, now why are these things equivalent? Well, let's take a look. So if we're looking at a fraction, if I divide the top and bottom of a fraction by the same number, I'm not changing anything, right? So for example, if I look at 6 over 4, you might notice that both of those numbers are even. So they could both be divided by 2 if I wanted to. Right? Now, if I do that, the top is going to be 3 and the bottom is going to be 2, which is the same as the first number. Right? So that means that they're equivalent fractions. right? And I could do a similar thing with 18 over 12 and 72 over 48. Let's just do 18 over 12 real quick. I could divide the top and bottom of these each by 6. And of course, that would give me a 3 over 2 as well. So since I could divide the top and the bottom by something and still end up with 3 over 2, that means that those fractions are equivalent. All right, so that's what we mean here. So let's find some equivalent fractions. So in part A, we're saying that 7 over 3 is equivalent to something over 12. All right, now one way that you can find this is that you could cross multiply. All right, but I want to avoid that because I really want to sort of stress home the idea of this sort of equivalent fraction thing. All right, so the idea is that to go from 3 to 12, you either have to multiply or divide by something. In this case, you have to multiply. What do you have to multiply by? Well, of course, you have to multiply by 4. So if I do that, I better do the same thing in the top. And if I do 7 times 4, I'm going to get that this question mark really should be 28. Right? So 7 over 3 is really equal to, 28 over 12. And of course, if you divide by 4, if you undo that multiplication by 4, you do get what you started with. So that's an indication that they're equivalent fractions. Okay, now in part B, we want to do something similar. We have 5 over 4 is equal to question mark over 20. And of course, in this case, I'd have to multiply by 5. So I better do the same thing up top. So then that would mean that this is equivalent to 25, since that's 5 times 5 over 20. Right, and then in part C, we have 6 is equal to question mark over 4. And of course, we want to think of 6 as 6 over 1. So now how do I go from 1 to 4? Again, we need to multiply by 4. So I better do the same thing here. If I do 6 times 4, that gives me 24. All right, and then last but not least, we have a 2 over 3 is equal to 8 over question mark. Okay, now just because the question mark is in the bottom doesn't mean that we approach the problem any differently. To go from 2 to 8, you still need to multiply by 4. So I better do the same thing in the bottom. If I do 3 times 4, I get a 12. So then 2 over 3 is the same thing as 8 over 12. All right, so the bottom line is that all of these give us equivalent fractions. Okay. Now, one thing that is really sort of an important consequence of talking about these equivalent fractions is talking about what's called reduced form, right? Now, a fraction is in reduced form if you basically have the numbers on the top and the bottom as small as they can be while still being equivalent to the original fraction, right? So to obtain reduced form, you essentially divide the top and bottom, of course, by the same numbers. Until you can't anymore. All right, and of course, if you pick your first number wisely, then that sort of cuts down the time, and I'll show you what I mean by this. So if you have 28 over 12, one option that you could do is you could divide both of these numbers by 2, right? I think that's easy to see. Both of these numbers are even, so you can always divide by 2. Now, if you do that, in the top, you're going to get 14, and in the bottom, you're going to get 6. All right, but these numbers are still both even, so we could do this again. We could divide by 2 in the top and the bottom again, and we would get a 7 over 3 this time. Now here, we can no longer do this, right? Because I could only divide the top by either 1 or 7, and I could only divide the bottom by 1 or 3, and I can't, dividing by 1 doesn't change anything, so I'm stuck here, right? So that means that this is reduced form. Right? So the next idea is that we have the possibility of also getting this a different way, right? So we could have also divided the top and the bottom each by 4. And if we do that right away, we get the 7/3. Right? So of course you can do this in a number of different ways, but a lot of times it's easier to see the top way because you're dividing by smaller numbers, right? So even though it might take you multiple steps to get there, that's usually the easier one to see. All right, so let's do a couple more reduced form. So for example, if I have 15/27, looks like that one we can divide the top and the bottom by 3, and we get a 5/9. And then in part B, we have a 22/60. And let's see, off the top of my head, I think the best we can maybe do is 2. And it looks like we'll get an 11/30. All right. Now part C, I know the quick way, but I'm going to do it sort of the way that I think most people would see. Now, if you have 90/15, both numbers end in a 0 or a 5, so you could divide each of those by 5. Okay, if you divide 90 by 5, I believe you're going to get an 18. And if you divide a 15 by 5, you're going to get a 3. All right, but of course you could divide each of these now by 3. So that's going to give us a 6/1, which is just 6. All right, and of course the quick way to do this is that you could have just divided 90 and 15 each by 15, and right away you get 6/1, right? But I think it's usually easier to see the 5 and then 3. All right, and then last but not least, part D, we have 32/12. So in that one, we can divide the top and the bottom each by 2 again. Let's just do it. And we get a 32, sorry, I divided by 2, so I got a 16/6, but then we can divide by 2 again, and we get 8/3. All right, and those are some examples of obtaining reduced form. Okay, now a quick note here is that that goes to sort of cancellation, or if you want to divide, you have to look at the entire numerator and the entire denominator, right? So for example, you might be tempted to say that this is 2 plus 5, right? Because if you look at 6 divided by 3, you get 2, all right? But you have to be a little bit careful here, because what this is really saying is that this is 6/3 plus 5/3, right? So of course this first part is 2, but the second part is 5/3, all right? And that would be different than saying this, for obvious reasons, right? So you got to be careful there. Okay, so now that we've talked about multiplying fractions, we've talked about obtaining reduced form and equivalent fractions, we can now talk about adding or subtracting fractions. Now, if you want to add or subtract fractions, you need the fractions to have the same denominator. So you need them to have the same number on the bottom, right? Now, of course, if they do, you just add or subtract the numbers and you keep this denominator the same, right? So if you have 1/4 plus 2/4, you get 3/4. If they don't, which is usually the case most of the time, you first need to find the least common denominator. All right, so what do we mean by least common denominator? Well, we mean that the least common denominator is the smallest number that can be divided by by all of your denominators that you have, right? So if you want to find the LCD or the least common denominator, I usually say LCD, you're looking for the smallest number that each of the denominators that you have will divide. All right, and this sort of is one thing that comes with practice, and the more you look at them, the easier this will sort of come. But let's look at an example. So if you have 1/2, 5/6, and 4/9, we want to find the LCD. So I want the smallest number that all three of these things will divide. Now, if you look at, we have 2 here. So here's sort of the long way to do this. If we look at 2, what are the different multiples of 2? Well, we could have 2, 4, 6, 8, 10, 12, 14, 16, 18. I'll go as far as I know I need to. If you look at 5 over 6, which denominator is 6, we have 6, 12, 18, 24, and so on, right? Could do this. And of course, if we look at 9, we have 9, 18, 27, and so on. And we're looking for the smallest number that appears in all 3 lists, right? So of course, if you look at this long enough, you'll find that 18 is the first number that is going to appear in all 3 lists, right? So that means that your LCD is 18, least common denominator. Is 18. All right. Now, once you have that least common denominator found, you can now go talk about how to add fractions that have different denominators. All right. I must have, did I skip a slide here? Okay. So the idea is that once you have the least common denominator, you now want to make all the fractions into equivalent fractions, but in a way so that they all have the same denominator. All right, so let's look at that. So for this example in part A, we have 2 over 5, 3 over 4, and 2 over 3. All right, now of course all these denominators are different, so we can't add them or subtract them right away. We need to find the LCD. All right, so denominators are different. Need to find the LCD. Now, I'm not going to do this in the long way as we did before, but the idea is still the same. You want to think about all of these different numbers and what's the smallest one that all 3 of these will divide, right? And one good way to do this is you look at the biggest number, right, which in this case would be 5, and then you check all the multiples for that. So if you look at 5, obviously 5 doesn't work. If you look at 10, 10 won't work either. 15 works for 3, but not for 4, right? And then if you go to 20, 20 works for 4, but not for 3, right? 25 doesn't work for either of them. 30 works for 3, but not for 4. 35 works for 4, or sorry, 35 doesn't work for either of them again. 40 works for 4, but not for 3. 45, will that work? No, 45 will not work either. Let's see, will 50 work? 50 will not work, right? And then will 55 work? 55 will not work, but I believe 60 will, right? So in this case, the least common denominator is 60, right? So now the next step is I need to convert all of these fractions so that they all have a denominator of 60. Right? So what I need to do is I need to multiply each of these fractions by something that's going to make the bottom number 60. Right? So to go from 5 to 60, I would need to multiply by 12. So I need to do that to the top and the bottom. To go from 4 to 60, I need to multiply by 15. So I better do that to the top as well. And to go from 3 to 60, I need to multiply by 20. So top and bottom there as well. Right? So if I do that, I'm going to bring that down here now. I'm going to get 24 over 60 plus 45 over 60, and then minus 40 over 60. And let's see, if we add all these together, it looks like I'm going to get a 29 over 60. Right, so we get 29 over 60 there. All right, now let's look at part B. So for part B, we have 2 over 3 plus 4 over 7. Okay, so same thing here. Part B, 2 over 3 plus 4 over 7. All right, so we need these to have the same denominator. So 7 won't work for 3, 14 won't work for 3, but 21 will. All right, so this one I need to multiply top and bottom by 3. This one I need to multiply top and bottom by 7. So I get a 14 over 21 plus a 12 over 21. So we get a 26 over 21. All right, so that's what happens, and I add 2 over 3 plus 4 over 3. All right, so that's how we add and subtract fractions that have different denominators. All right, now let's look at ones that are a little bit more tricky. Okay, so in this first example, we have 1 over 2 minus 1 over 6 plus 1 over 3. Okay, now here you can actually see pretty quickly that your least common denominator here is going to be 6. All right, so if I want my denominator to be 6, I just need to multiply the top and bottom of the first one by 3. So let's do that. The second one I can actually leave alone, and the last one I need to multiply by 2. All right, so it looks like I'm going to get a 3 over 6 minus 1 over 6 plus 2 over 6. So if I add and subtract these all together, I get 3 minus 1, which is 2, plus 2 more, which is 4 over 6, which I can reduce to 2 over 3. All right, now in the second one, we have a whole bunch of fractions going on. So we have 4 over 3 minus 1/2 over 1/3 plus 3 over 4. So what we're going to do here is we're going to subtract the numbers in the top. We'll get a new fraction for the top. In the bottom, we'll add those two, and we'll get a new number in the bottom, and then we'll do our keep change flip. All right. So in the top, let's look at, let me do this sort of off to the side. So I have 4 over 3 minus 1/2. So here again, my least common denominator is 6. So if I multiply here, I'm going to get an 8 over 6 minus 3 over 6. So that's going to give me 5 over 6. So that's my new number up top here. I get 5 over 6. If we look at the bottom off to the side, I got 1/3 plus 3 over 4. So my least common denominator here will actually end up being 12. So this one needs to get multiplied by 3 and this one by 4. So we get a 4 over 12 plus 9 over 12. So that gives me 13 over 12. So that's my new number here. Now, if I do my keep change flip, I'm going to get 5 over 6 times, instead of 13 over 12, I'm going to get 12 over 13. All right. Now, if I multiply here, I'm going to get that this is 60 over 6 times 13, I guess would be a, what is that, a 78? And of course, here we can divide the top and the bottom by 6. And we should get in the top, we're going to get a 10. And let's see, in the bottom, we're going to get a, let's see, so we get a 30. Is that, let's see, is that 37? I want to, no, 36 times, no, not 30 something, I don't know what I'm thinking. So if I do 6 times, I should get 13, right? 10 over 13. Yeah. Oh, okay, yeah. And this brings up another good point we could say here. Now, the order of multiplication and division doesn't matter, right? Or sorry, the order of multiplication doesn't matter. So I could just as easily say this is 5 times 12 over 6 times 13, which is 12 over 6 times 5 over 13, right? But what's 12 over 6? This is just 2. So then if I multiply 2 by 5, I get 10, and 1 by 13, I get 13. So one thing that you can do here is you can look to cancel here. You could have just said that 12 divided by 6 is 2 and simplified it that way. All right, but that's one thing that maybe you'll do once you get more comfortable. Okay, part C, we have 3 over 2 plus 5 over 9 minus 1 over 3. Right, so my common denominator here, I believe, will be 18, right? Multiply this by 6, this one by 2, and this one by 9. So I'm going to get 27 over 18 plus 10 over 18 minus 6 over 18. So it looks like I'll get, when all is said and done, a 31 over 18. And of course that I can't reduce. All right, now part D, we have a 2 over 3 plus 5 over 6 all over a 1/2 plus 2/3. So it looks like my common denominator in both the top and the bottom is actually 6. Okay, so if we simplify here, I'm going to get a 4 over 6 plus 5 over 6 all over a 3 over 6 plus 4 over 6. So we get 9 over 6 divided by 7 over 6. So now if we if we keep change flip, we'll get a 9 over 6 times 6 over 7. And here we can think of canceling the 6's out. If you multiply it across, you should be able to divide the top and bottom by 6 anyway. But either way, you'll end up with 9 over 7. All right, so that's your example there. So those are some trickier ones, but that's the idea. Okay, now the last thing that we can talk about in this section is the idea of percents, right? Now percents sort of relate to fractions because if you say percent, that means that you're just putting the number over 100, right? So if you have 7%, that really means you're taking 7 out of 100, right? So what you could do is you can convert back and forth between percentages and decimals by moving the decimal place 2 points to the left if you wanted to convert a percent to a if you want to convert a percent to a decimal, you move it 2 places left. And if you want to convert it back to a percent, you move it 2 places to the right. And of course, adding the percent sign, right? So as a couple of examples here, or actually I should say first that if you wanted to write a fraction as a percent, you just multiply by 100 and then simplify that fraction that's left, right? So for example, if you wanted to look at 1 over 20, multiply that by 100, you would get 100 over 20, of course. But if you divide that, you just get 5. All right, so of course, 5%. All right. So in this example, we're going to look at writing each percent as a decimal and also as a fraction, and each of the decimals or fractions will convert to a percent. All right, so the first two, of course, would be converting to a decimal. All right, now in the first one, you have 25 over 100. So first we'll write it as a fraction. And of course, you could reduce that to 1/4. Right? If I wanted to write it as a decimal, I could just take the 25%. My decimal is technically right here. If I move it 2 spaces to the left, I get that that's 0.25. Right? Similarly, if I do 142%, As a decimal, that's 1.42. And if I do this in fraction form, I got a 142 over 100. Let's see, which we could reduce to maybe, let's see, a 71 over 50. Is that the best we can do? I think so. Okay, so we get a 71 over 50 there. All right, now for part C through G, we're either given a decimal or a fraction, and we want to convert that to a percent now. So now we're sort of going the opposite direction. So if I have 0.6 and I want to convert that, sorry, I don't know why my screen's doing that. If I want to convert that to a percentage, I just now need to move the decimal place the other direction. Right? So if I move the decimal here, this is going to give me a 6%. And of course, that would be writing 0.06 as a percent, which is now 6%. Okay. Now, if we do the same thing for 2.1, all right, that's given to me as a decimal, and I want to convert that to a percent. So I move 2 spaces to the right. Now we have this empty gap here, so I'm just going to fill that in with a 0, and that's going to become 210%. All right, for part E, we have 3 over 4. And since I'm given a fraction, I'm just going to multiply that by 100. All right, so I'll think of that as 100 over 1. We get a 300 over 4. And let's see, if I divide the top and the bottom by 2, I would get a 150 over 2. Right? And of course, if you wanted to write this as a decimal, you get a 75.5%. Okay, for part F, we have 21 over 5, which if we multiply by 100, let's see, we'll get a 2100 over 5. And if we divide the top and bottom by 5 now, we should be able to get what we want. We should get a, I think this is a 420%. All right, and last but not least, part G, if I do 1 over 6 times 100, I get 100 over 6. And this probably does not work out cleanly, but let's just check. If we do 100 divided by 6, that would go in, let's see, so 10 would be 60, another 6 would be 36 to 96, so it's going to go in 16 times. And then with what, 4? Yeah, 4 left over, so that would be a 667. So, and for this part, you could just use a calculator. So you get a 16.666 repeating there. Okay, so I think these are the last 2 slides. So now we'll talk about how to find the percent of a number. All right, so if you want to find the percentage of a number, you're just going to convert the percent to a decimal first and then multiply. Okay, so for example, part A, we want to know what is 30% of 15. Right, so 30% I would want to say is 0.30, and then multiply it by 15. So if I do 15 times 0.3, all right, this is a good way to refresh. You're just going to multiply as if the decimal isn't there. 3 times 5, of course, is 15. We carry the 1. 3 times 1 is 3. Add 1 is 4. And now we just need to move the decimal place over however many times it appears. So here, decimal place is moved once. So this is 4.5. All right, for part B, if I want to do 5% of 400, right, 5% is a 0.05. So if I multiply these, right, you can think of this as 5 times 400, really. right? So if I do 5 times 400, I'm going to get 0, 0, and then a 20, right? And the zeros won't give me anything. So now if I just move the decimal place over, I'm going to get that this is 20. Okay. For part C, we'll need a calculator for this part, but I have a bank that's paying 6.75% interest. And we want to know what is 6.75% of a deposit of $500. So I need to move this decimal place over, and I get a 0.0675 times 500, right? So let me grab a calculator here. I just had it here a second ago. Okay, here it is. So now if I multiply these two things together, I want to do 0.0675 times 500, and that gives me a 33.75. All right, so of course that we would use a calculator. All right, and part D, price of a refrigerator is going to be reduced by 20%. We want to know what is the sale price. All right, now there are two ways that you could do this. You could find what the amount of the discount is going to be and then subtract that from the original amount. Or if you take 20% away from something, there's 80% remaining. So you really want to find 80% of 600. All right, so I need to do 0.8 of 600. Right, and if you do 6 times 8, that is a 48. I need to add 2 zeros for the 600 part, but then I need to move the decimal place one spot for the decimal, so this will be a 480. All right, so that concludes this video on doing some arithmetic operations with fractions. I hope you enjoyed, and I will see you next time.